Hey, this is Justin from PAX, and I had a lot of requests um, to talk more about these ideas of software principles. People really received an earlier article I wrote very well, where I was talking about software cockroaches, and I had listed out a bunch of advice I wish I had a long time ago. But it was very dense, and people asked if I could boil it down into some general principles to keep in mind when coding, or if you're a manager or a coder, what would the takeaway be here? How do you support like how do you apply this knowledge in a broader context? So this is my attempt to write about just that. I'm going to leave the article here, but I'm just going to breeze through the talking points. And I've kind of extracted what I believe are three core principles that separate teams that are low performers, or teams that do a lot of work but have a hard time delivering. And I've sort of separated what's the core difference between teams like that and teams that have a tendency to ship lots of stuff on time before schedule and generally enjoy, teams that work on frameworks, and the frameworks allow them to work faster, and then they write more code that automates, and they enjoy this exponential increase in productivity over time. Essentially, I've attempted to boil down what those principles are, because it's easy to see instinctively if you have experience, but if you're learning these skills, it can be a really non-linear process to gather enough information to enjoy that kind of productivity. So this is my attempt to sort of structure that with natural language, and to share those principles. Of course, these are my opinions. You might say I'm completely wrong, and that's fine. These are just the path. This is just the path I found to that kind of productivity and that kind of flow within software teams. So the first is something you may have encountered, but it's that reading is greater than writing. Um, Basically, you're going to write your first version of your system. It's going to be, say, 10,000 lines of code. Your system will be mature when it boils back down to 7,000 lines of code and tackles 5 times the features. So in general, you get from the 10,000 to the 7,000 lines of code by having lots of people look at the code base, and lots of experts rack their minds, or try to wrap their heads around the code base and team up to try to figure out how to simplify processes. And what that means is that you actually end up with a reductive set of commands for the computer that allow it to reach the same set, that allow the computer program to execute and have the same effects that it had before, plus extra. So, an expert can walk into a system with 10,000 lines of code, delete a few lines of code, add in a few variables, and actually increase the feature set sometimes by 2x. And generally, lines of code, measuring your lines of code, measuring the amount of writing happening, is not a good indicator of a positive impact on your system. In fact, generally speaking, once you get past a certain point in your development, you want to commit as few lines of code to your system as possible while supporting a large amount of features. And you accomplish this by baking into your software culture that reading and review is more valuable than writing. Right? Writing lots of code is not impressive. Editing other people's code, coming up with new solutions using what's already there, is impressive. That's where expertise comes in. Software teams that focus on abstraction have a tendency to do a lot better. The first step in abstraction is extracting all your configurations and your variables to a central location. So, declare your variables at the top of the file. This is kind of like basic beginner stuff that you get good at after a few years, because sometimes it can be hard to take a low-level variable and propagate it all the way up to the top of a framework. It's not clear all the time how to do that. But there is a whole other level of meta-consciousness that goes on, which is, what's our choice of what to abstract, and how do we boil that all down to a single line of code that orchestrates many, many events? And this is where expertise creeps in. And once you get that low-level one line of code interface that's battle tested, you can now transfer your system. You might be shipping a system that's 5,000 lines of code that requires 25 variables to be configured, but you can ship it with one line of code, and other people can leverage it instantly. And so abstraction is very powerful for allowing ideas, the battle-tested, well-read ideas. You can allow them to be delivered and moved around because you've abstracted them properly and modularized them properly. It's not easy to do this, and it takes practice. Third, generally speaking, teams that perform well have a focus on people, not on the compiler. The compiler will just tell you when you're wrong, and people that run things on their own local computer or throw things up on a server and then forget about them, or teams that behave this way, will enjoy a certain amount of success, but they have a tendency to become siloed and brittle. Meaning you have many people who understand many different things, but don't have a shared vision and don't even have a shared language with respect to how they share their own code artifacts. And teams can run this way indefinitely. It's not very productive. But teams that function well invest in the sort of, I would call, the editorial process of coding, and they also engage with users early on. So what you do is you grab your end user, and during development you bring them in. You say, hey, this is a software package, these are the numbers that are spitting out, what do you think of these numbers? And then the client says, I don't know what you're talking about, and right away the developer has built empathy. They understand what's going to fail or not in the end user's eyes, and they can reorient their work right away. And that propagates into the efforts with abstraction. What do we abstract? What are the one or two lines of code that give leverage over the system? What are the most important two lines of code? And how do I make sure that the system is written in a modular and intelligent way to allow for the abstraction, to allow for these people to have the required leverage over the system? So these are kind of, focus on reading. 80% of the time should be reading and editing. Focusing on editing with the purpose of arriving at suitable abstractions that are presented to people that they can then veto because they don't work. This loop is the loop that leads to essentially automation, right? So essentially what this is the process that drives automation within your business unit and also within the community. Because when you ship software that goes through this process, then your users have less questions, and you end up aligning very, very quickly with your end users. So that's it. These are, I think, the three main principles that one should consider when trying to write or codify systems for teams. And if you're interested, visit the Medium article. And if you have more comments, the comments have been very great. So keep them coming, and I'll keep sharing content. Thanks. Bye.